at the beginning of this tutorial, I want to give a short recap of the Cyprotec 5 online configurator. And today we are talking about a centralized busbar protection. And for this, we prepared a small example configuration for this centralized approach. And this can be seen here on the slide. We have a double busbar with 4 feeders and 1 coupler. 2 feeders on the left side of the coupler, 2 feeders on the right side of the coupler. And the coupler has 2 CTs. Okay, so let's check what are the bullet points for the configurator. We have 4 feeders and 1 coupler, so 5 bays on total, and 6 current transformers in this overall configuration. We have a double busbar, and in this case, for this, we need 2 bus zones. The disconnector image is necessary because independent of the disconnector position, a CT can be assigned to the different bus bars, and whenever this is valid, you need a disconnector image. So the significant feature I want to choose later is the 2 zones with 4 bays and including the disconnector image. The functions we want to configure today is the 50BF, the breaker failure protection, 50EF, the end fault protection, and the bus coupler differential protection. And yeah, let's talk about binary inputs. Here I want to configure 8 per feeder bay. The 8 bays are for 2 for each disconnector, means 4 with these 2 disconnectors, 3 for the circuit breaker, where 2 of them are for the circuit breaker position and 1 for the circuit breaker close command. And the number 8 of the binary inputs that we need is the start signals for the circuit breaker failure protection. For the coupler bay, we only need 7 binary inputs because there we don't want to configure additional circuit breaker failure protection. So much about this example. Let's jump right into the online configurator. And yeah, this is the online configurator surface here. I will switch to full screen and zoom in a little bit. I hope it is now good to read and see for you. We start by selecting here the device. And it is a Cyprotec 5 device. Okay, so here's the overview about the device types that can be selected. We are talking about busbar protection, so this is what I choose here. And I also jump over this quick description. I think we are above this point. Already know more. Okay, now this is the point where you choose the significant feature. So the first 6 significant features are the ones for the centralized busbar protection and for the IEC 61850 compliance solution, and the other 5 options here are for the 7SS85CU distributed busbar protection. But today the first 6 ones are the interesting ones, and as I told earlier, I want to choose the option here 2 zones, 4 bays, and including the disconnector image. So confirm the step with next. And here you have the option to choose your standard variant, which one you want to start with. And I chose in preparation that I want to start with the standard variant V2. And confirm the step again. And here on the top of this site, you always see the overview of the device like you already selected it. So you see the base module, the expansion module you choose, and how much binary inputs, binary outputs, and current transformers are available. And as we see here, current transformers are 16, or here below it's 4 times these 4. And as we saw in the example earlier, we need a setup with 6 current transformers, so this is not sufficient. And this is where I want to start right now. So I go to add and remove modules to add an additional expansion module. And here we can see is already one IO 203 selected. And here I increase this number from 1 to 2. And then we can check in the overview. Now we have 6 times 4 current inputs, and this is sufficient for our setup. Okay, but scroll to the top again. Now we see here we only have 15 binary inputs and 15 binary outputs at the moment. And as I mentioned earlier, we want 8 per feeder bay and 7 for the coupler bay. This means we need 39 binary inputs in total, so 15 is not yet sufficient. That means we need another expansion modules for to get more binary inputs. And for this I choose the IO 231 here. Okay, and scroll down up to the top again, and now we see we have these 39 binary inputs, which is exactly what we need, so we can go with this setup as it is shown here. Okay, I go to this next step to the plugin and communication modules. Of course, for a centralized busbar protection, in difference to the distributed one, we need there are no communication modules mandatory, but typically we need a module for substation communication, and for this reason I add the Ethernet BB module here. Okay, so confirm the step. Maybe now this is a little bit too much zoomed in. I get a little bit smaller now. Okay. So here once again the overview about what we already selected. As we can see also here it is still a small display, and this is what I want to change now. Because for busbar protection it makes always sense to go with a big display or a large display here. Because as soon as you want to display some of the single line elements, for example, it is nicer to have more space on the display. So I choose this option here. And then we still have to talk about the function points. So I open the function points calculator here. Of course, the main protection functions like the busbar differential protection or the inherent circuit breaker failure protection are already included. But we want some more functionality. And as first I start with the function points for the necessary base. Because I hope you remember our example has 5 bays, but in our significant feature we have only 4 bays included. This can also be seen here. So there's this check with that 4 bays are already included, but we need 5 here, so I increase this number. Okay, then right above this bay option, there's the bus coupler differential protection. This is a function we also would like to configure or to demonstrate here in this tutorial. So I choose this another 50 function points for the bus coupler differential. And then we need the end fault protection and the circuit breaker failure protection. So here's the end fault protection. These 5 points we need for all the 5 bays. So I increase this number here to 5. And the circuit breaker failure protection, here I go with the 3-pole option. And this is a functionality we want to configure only in the feeder bays and not in the coupler bay. Yeah, because typically the external faults happen in the feeder bay and not in the coupler bay. So this is a number I only have to increase to 4. Okay, and let me check my notes if I missed something. No, it looks good. So these 185 points are all we need. So I apply this and scroll to the top. Here you can see the shortcode and the long code of the device we created. And of course you can save this option as PDF. And yeah, with this short code now, Rainer is good to start with his configuration.
For today's tutorial, we want to demonstrate really an example from the beginning. Nina now has configured a small centralized busbar protection. I will configure exactly the substation Nina has shown. And with this configuration I will do now with Dixie 5. Nina will afterwards demonstrate some faults and tests in the digital twin. So we really want to demonstrate here really an example step by step from the beginning. Okay. I have already opened Dixie 5, and first step we really want to start really from the beginning. I will create a completely new project. Project new, and I would say yes, project 2023 and the date of today. That's fine as a name of our project. Needs every time a little bit. And Nina is behind me to be careful that the project, the device I will create will exactly fit to the setup of her demonstration in the digital twin. So configuring busbar protection, especially a centralized busbar protection, has every time 3 major steps. In the first step, I will create the single line diagram, exactly the single line diagram from the substation you want to protect. In the second step, I will create the device and all the necessary elements in the device. And in the third step, I will assign the elements from the single line diagram to the elements of the device. And these are mainly the same parts independently, whether you will configure a centralized busbar protection or a distributed busbar protection. Maybe there are some difference to make it a little bit more efficient between the centralized and the distributed, but they are quite low. In the first step, I will start to create the single line. So I open the single line configuration. I adapt in the first step the zooming, I would say 80% should be fine. I will just delete. I go to the libraries. I open the global Dixie 5 library. I open the types, and I will start with the single line elements. And here in the single line elements we have protection templates. And I open the protection templates, and we will start, as Nina has said, she wants to show us a double busbar configuration. I will start with a double busbar and line feeder template. You could see it here. So far fine. So
but please change the assignment of the disconnectors to the busbar. So the left one to the lower busbar.
A special feature from Nina.
How I did my configuration.
I did it in this way in 10 years, but Nina,
sorry.
no problem. So, but thanks for the hint. I would already have forgotten this once again. So, that's fine. Already extend a little bit the boson. So we need for base, Beidou, and a coupler bay in the middle, when I remember correctly.
Yes.
And bus coupler, and here we have a coupler bay. Not necessary at the moment. We have already the bosons, so we will delete. Oh, this was, I clicked wrongly. Second try. place it here. And I guess you once again want to connect the right side to the upper bus zone.
Exactly, yes.
So it has to be consistent. Oops. And we want to have a coupler in the so-called overlapping arrangement to have a very fast clearance time. And okay, but we will have also the bus coupler differential protection, so we will demonstrate both, but here the CTs are arranged not very well for busbar protection, and so I have moved one of the CTs to the other side of the circuit breaker, and so in the first step I have to delete the connections. Pick it up, place it here, connect it to the other side. That's every time a little bit tricky. So the coupler looks fine, but we need 2 feeders more. Okay, copy this feeder, paste it.
If we really want to do the same configuration I did, you have to change on this feeder 3 and 4 the CT to the line side. So for the first 2 bays, it is
okay,
bus
give me a moment.
and
Let me first finish
yes.
the single line
Sure.
elements. So, bay 5. Oh. This one. And I remember I will come to your position of the CEDA once again. I guess we should call this coupler.
Mm-hmm.
So, get the coupler. And which feeders? Right.
3 and 4 line side.
3 and 4. Okay. Oh. Let's shift a little bit. They are line side, neither. No, both CTs are line
yeah.
side. Do you want to change the other ones to busbar side?
I think I did it, yes, but I just...
Okay. Shall I
know,
change it
just
to
leave it
busbar
like
side?
this.
Okay. So now I was a little bit confused, sorry.
Yeah.
Because now I mentioned it's already line side. Both of
True.
these current transformers are line side. For busbar protection, of course, we will need, especially in the feeder, only one CT, but I will demonstrate it's not necessary to remove it from the overall CT. We simply will assign only one CT to the busbar protection elements, so it's absolutely fine. I get the next thing. Now we want to change the color of the bus zones. Here are the bus zones for the coloring in the online monitoring of in the single line, either in the web browser or in Dixie 5. To do this, I will open once again here the properties. I will select the busbar 1. And we see here the online color, and the upper side was
red.
red. So the upper bus zone will be the online color red.
And the other one green.
I select the other one. It's green, and here, oops, a little bit deeper. Now it's green. What else should be changed? The primary rated current. The primary rated current of the feeders. Here could see is the default value is 1000 amps. It's fine for all feeder bays, but the coupler bays, I think that's should be quite near to reality. So typically in couplers between bus zones, current could be much higher. So typically there are a higher rated CT in the coupler, and we have decided here for 2000 amps. So I will select the CT or the CT2 in the coupler, and I will change the rated primary current to 2000 amps. And I will select the second CT, and it's also 2000 amps. Save. Okay, Nina, I am ready with the single line diagram, or have I forgot something? Okay.
Looks good.
So first step, I have finished now the single line diagram of the substation to be protected by our busbar protection device. Second step will to create the device and all necessary elements in the device. Before you need the device drivers, the Dixie device drivers, the DDDs. I will just show you which DDDs I have imported. We are selecting tools and go to manage device drivers. And so you see that I have imported device drivers of the communication protocols. More necessary in the next tutorial when we are talking about the distributed busbar protection, but also typically necessary in a centralized busbar protection, because nowadays really every device, especially a busbar protection device, has a connection to a substation communication. So here I have several merging units we will need in our last tutorial. And for busbar protection we have the 7SS85. We have from version 8.84 until version 9.40. 9.40 is the newest one, and I will create for our demonstration, of course, the newest firmware version, the 9.40. And what again is very important to see really is that we have one device which is able to make a centralized busbar protection, a distributed busbar protection, and it's only one firmware, it's one code, it's one device where you can figure really all different types of busbar protection. Okay, that should be. Let us create a centralized busbar protection with the product code Nina have created. Add device, that's the P1E 118070. Let's verify. There are, for busbar protection, there are not so much application templates because simply the variety is so large it makes no sense. So we have really only a basic template where we have one bus zone. We will select them. And for the communication protocols using the firmware version 9.40, there are also no options. So you must use the 9.40. And I say OK. And now typically we have to overbridge some time when Dixie 5 is creating the device. So importing CFC, some CFC functions. Okay, the device is ready. Let's have a look to the device view. I select the device, the 7SS85, and we can check whether the product code really created the device Nina has configured. It has a large display, only 16 LEDs, and 3 extension modules, and 2 IO203 and 1 IO231. So that's fine. Okay, before we will create the elements, we will, in the first step, create the measurement points. We go to the, we open the device. We open the device. We go to measurement points routing. And since, I think since 2 years, we have the very nice features that it's possible to create in one step not only one additional measurement point. We can already create in our example up to 6 measurement points, and they will be automatically routed to the available CDs in the 7SS85. So we have, for busbar protection, only 3 phase measurement points are allowed, and the count 4 feeders and 2 CDs in the coupler, we need 6 measuring points.
And then it makes sense to rename them, that it is to keep a better overview about the measuring points and the connections between the base and the measuring points.
Especially when you will see later in the, when we make the assignment between the elements of the device and the single line element, and it's very helpful to be sure which measurement point should be assigned later to which bay. And therefore, as Nina proposed, we will give the naming of the measurement point according to the bay. We will assign them later. That's bay 01. Bay 02. Oops. Bay 03. I see no problems. Do you have problems with my voice? Yes, okay. Sorry. Excuse me. We have a little bit problems with my sound, as it seems. Okay. Okay. I will continue. Bay 4 and the 2 measurement points for the coupler. That's couple the first one for the coupler and the second one for the coupler. 2. Okay. Now we will create the additional elements in the device. And therefore there are different ways how to do this. You can drag and drop them from the library to the settings or into the routing matrix. As for the busbar protection, we have to work anyway a lot with the single line editor. I will do the same by drag and drop them to the element to the device in the single line editor. So I will close. Normally we should see here this device, the 7S85, and the first step you see we have at the moment only one bus zone, but we have a double bus bar, so we need an additional bus zone to assign them later. So we are here in the global Dixie5 library, types busbar protection, 7SS85 busbar protection, function group busbar, busbar protection. It's a little bit exhausting, I know.
Good hidden.
But sets according to the structure in Cypriot 5 and in Dixie 5. And here we have the bus zone. And we will drag and drop them to the busbar protection. And now we have 2 bus zones. And we need a bay. So we will drag and drop a bay. That's the bay 1. So let's finish the first bay first. Let's start with, according to routing, we started with a circuit breaker. So let's create also the circuit breaker first to have the same order. Bay, okay, I have to open the bay and the function group, sorry, a little bit 3-ball. I guess you have chosen a circuit breaker 3-ball.
Yes, yes.
That's enough. So we have a circuit breaker. And should we create? Oh, let's already create the additional function in the circuit breaker. Makes it a little bit more quick here. We need
Endfault protection and circuit breaker failure protection.
So let's start with the circuit breaker failure protection. It's here. See, oops, the advanced circuit breaker failure protection have to be put on the circuit breaker, and the endfault protection 50EF we have also to put here. Anything else? No? Yep. So now next step will be the disconnectors or the current transformer, doesn't matter. No. Oh,
As you like.
Let's create this disconnectors. Function group circuit breaker, you have function group disconnector. And the disconnector 1 and the second disconnector.
And it is really a nice feature that we only have to do it once and then copy the bay. That saves a little bit of work.
Also well, quite new knot. In the meantime, I guess implemented since 1 year, but me as a PLM for Busbar protection had to be wait for this feature some years. So some features need a little bit more time, but now it's available. Very fine. Okay, and I guess we still need a current transformer. Where is the current transformer? Here's a function group current transformer, and I need a current transformer. Okay, as Nina has already said, 2 years ago we would have to create all these elements here once again for all the bays, but now it will be possible to copy the bay, and therefore before we will copy the bay, it's a good idea to save time to complete the first bay as kind of a typical as much as possible before copying, because it saves a lot of time, a lot of money in this case. Okay, now what we want to do, we have to go, let's start with the settings. Let's go to the settings, bay 1, the circuit breaker, and here's the circuit breaker failure protection. Okay, this will be too later. What is important, the start via binary input we will do, because it's used as an external circuit breaker failure protection, and I guess it's one, or
I choose the one channel option.
One channel. Okay, we
and
have a
retrip T1.
And retrip T1. Retrip after T1, it's no. So we have here parallel stat, I guess.
Parallel, yes.
Parallel stat. And the thresholds, the delay T1 is 50 milliseconds, the delay T2 is 130 milliseconds, and the threshold, where's the threshold? The threshold phase current, okay, we haven't assigned the current transformer. Okay, this have to be done. We will have a look afterwards when we have done the assignment. Maybe a little bit problem to make it too fast here at the very beginning. Okay, maybe not to disturb you. We can't see the threshold at the moment because up to now we haven't assigned the current transformer to the circuit breaker, and we will do this later, and then we will see also the default of the threshold. Okay, what's next? Routing and the unbalancing mode, or is it? Okay, we will demonstrate the circuit breaker failure protection in the unbalancing mode, but that's already the default value. Okay, I guess that's about the settings. Nina, We have forgotten the bus coupler differential. Also on the bus coupler differential potential is at the coupler. Okay, we will do it later. Okay, it's not so easy not to forget something, but I would say now we go to the routing.
Mm-hmm.
So information routing. Let's go to the bay, and we will start with a disconnector, the circuit breaker, and we will start with the position.
And open, high, closed, high was
Open, high, closed, high. Then
the close command for the info protection.
and the info protection is here. The close command. That's this one. High active. And the start of the circuit breaker failure protection. That's the fourth one.
Mm-hmm.
That's the start. High active. So we are finished with the circuit breaker for the moment. And let's go to the disconnector position. Next free one is a 2.1.
Also
high,
open, high, closed, high, yes.
closed high. And the disconnector of the status 2. Oops, it's open high, closed high. So, and of course we set the sources, the binary inputs, and we need to route at least the drip command of the circuit breaker. And to do this, I will collapse the sources, and here we have the binary inputs. Let's go once again to the circuit breaker, and here we have the trip open command, and we will use two unlatched, two binary outputs. So, what do you think, Nina? I am ready now to copy?
I would say so, yes.
That's okay. Let's try. Maybe we have something forgotten, so we will do it later. Okay. Oh, let's close. Sometimes it's a good idea to close all. Okay, we will start the copying here. We have here the bay 1. Right mouse click, say copy, click to the settings and say paste. And now I will be asked, do you want to route sequentially from the next available slot of binary values, means binary inputs, binary outputs, and LEDs while copying? If you select no, the routing will not be copied. Maybe a sense if you have anyway a different philosophy of routing your binary inputs and binary outputs, and then you could say no. If it's fine for you to make it sequentially, you would say yes. So for us in our demo, it's fine. So we would say yes. So we have already bay 2. Let's proceed. Copy. Paste. Once again, I will say yes. And last feeder bay, copy, setting, paste. Once again, yes. And last one, for the coupler, it will not fit exactly, but we will try it and say copy, and we will say once again settings, paste. And now maybe you may be confused as we have not been asked whether the routing of the binary inputs and binary outputs should be copied. The reason is that now there are not enough binary inputs and outputs available anymore, and if there are not enough, I decided the philosophy not to copy it partly, because then you have to see anyway which should be copied and not. So I decided as BLM, okay, if there are not enough binary inputs and outputs, don't copy any of the routings. And this has been done. Let's have a look. So opening the... maybe first, before I open the information routing, it's a good idea also to rename Bay 1, Bay 3. It's fine so far. We will later synchronize it anyway. But here, not to be confused, let us rename it to coupler. And typically, you don't need an circuit breaker failure protection which should be start external. Of course, we need the inherent circuit breaker failure protection, the circuit breaker failure protection, which will be started by a trip of a bus on anyway, but you don't need an external started circuit breaker mostly. Sometimes there are special configurations where we will also have an external start. But let's do here in this demonstration the most common things. And I will delete the external circuit breaker failure protection.
And then we need a second CT in this coupler.
Ah, thanks. I would have forgotten this. Okay, let's go here, the current transformer, and here, let's collapse. We have one current transformer up to now, and we need the second current transformer, and we place it to the coupler. So now we have two current transformer. Okay, and now maybe it's a good idea to create the bus coupler differential protection. Where function the extensions? Coupler zone. Okay, here's a coupler zone for the bus coupler differential protection, and I will place it to the coupler bay. Maybe, yeah, okay, as we are already in the settings, maybe let us change the setting of the coupler zone. We have the threshold for the one phase. Just for remember, if the restraint current is above this threshold for one pole fault, it will be changed automatically into the overlapping mode, where the two zones will be cleared very quickly. And the threshold for the one phase, I guess it was 5 amps. And the threshold for the multi-phase, that means the threshold of the restraint current when the bus coupler differential protection will be switched automatically to the overlapping mode. And this was, I guess, 1.
Exactly.
Okay. That's 1, and now we have to assign the routing for the coupler. As the routings of the coupler have not been copied, I open once again, and maybe let's have a look. Now here you see when all bays are really collapsed, how the sequentially routing have been done by Dixie5 during the copying. But now here it stops, and the coupler has no routing. And maybe let's, we had for each bay, we had 1, 2, 3, 4, 5, 6, 7, 8 binary inputs. But we have still 1, 2, 3, 4, 5, 6, 7 binary inputs have been available still anymore, and that's the reason this one missing binary input was the reason why Dixie5 has decided not to copy any routing at all. But of course we need, but in reality it's sufficient because we don't need the external circuit breaker failure protection. So we have to do the routing before. We start once again with the circuit breaker. And the circuit breaker failure, the circuit breaker position. Oh, where do I need where to start from. Okay, that's position. Okay, the 5.18 is the next one free. So I will start open high, close high. Circuit breaker and see
close command from the end-fault protection.
Exactly, the close command. The 5.20 high active, and we will continue with the disconnectors. Disconnector position and open high. Closed high, disconnector 2, and position open high, closed high. So Nina really exactly has tailored the device what we need. There's really no binary input free anymore.
Luckily I counted right.
Okay, and of course binary output. We should also the coupler, of course, should open. So we go to the circuit breaker, and here we have the trip open command. We once again collapse. So and now we need which sorry. How many binary inputs? Ah, yeah, okay, here we can see. So let's continue at 4.1. Breaker, oops. Trip open command, 4.1. Let's again. Yeah. Okay.
And you can go to the single line and do the connections.
Anything?
Right? No,
Maybe.
no, I don't think so.
Okay, we will see. Okay, to finalize, now we have finalized 2 of the 3 steps. We have finalized in the first step to create the single line diagram, and now we have finalized to create the device with all elements in the device, including the routing to the binary inputs and binary outputs. So there's still one major step left, and that is to assign the elements of the device with elements of the single line, and therefore I am open the single line configuration. Here I have the device, and I have already created an additional busbar, and in the first step I will assign the bus zones of the busbar with a single line busbars. That's fine. So the bus zones is already assigned, and to assign the elements of the bay to the single line bay elements, it's a very good idea to use this drag and drop availability possibility of the base. So you can here select the base, and we can make it in a 2-step approach and drag them here to the single line element. So bay 2. The coupler will be placed under the coupler, bay 3 under bay 3, and the bay 4 here. So here 2-stage approach. I have placed all the bays below the bay in the single line editor. We open the bay. I guess we don't need this at the moment. Let's start with the circuit breaker. We have to do this very carefully now, you remember? Okay, let's start with the current information of the circuit breaker, and we will assign every time the first current transformer to the current transformer inside the device. And now that's the reason it's a very good idea now to give a clear, meaningful name to your measuring points, and set the measuring point for bay 1. And we will assign the circuit breaker. Call up the circuit breaker. We will assign the disconnector 1. We will assign the disconnector 2. And we will assign the current transformer. Once again, bay 1. Okay. Now we have to do this for all 4 other bays. That's maybe a little bit exhausting. So if you need urgently a coffee, maybe it's a good time. But I have to do, and I have to be concentrated now to assign also the remaining bays to the elements. So once again, measuring point bay 2. Circuit breaker, disconnector status 1, disconnector status 2, collapse, it's a current transformer, that's a bay 2, save. Coupler, circuit breaker, doesn't matter which of the current transformer you will assign to the circuit breaker. You can use one of the two. So it's a coupler 1. And the circuit breaker is here. Disconnector 1, disconnector 2, current transformer 1, and the current transformer 2, of course. Here now definitely the other one has to be selected. Coupler 2. Okay, looks fine. Same for bay 3. Circuit breaker. Now it will be bay 3. This time it's working. Current transformer, disconnector 1, disconnector 2, and current transformer. Current measuring point for bay 3.
Okay, almost finished.
So, circuit breaker, last bay, bay 4, circuit breaker, disconnector 1, transformer. So. B4. Okay.
Well done.
Hopefully. To check whether it is really well done or whether I did maybe some mistakes, you have to make a first plausibility check. And if you go to the so-called filter view, here you have the filter view. And if you go here now to the 7SS85, the algorithm within Dixie-5 to really interpret the topology of the substation the device has to protect later is running. And if something is implausible, when I forgot something to assign, or when I assigned a measuring point of one bay to several bays or anything else, it will be refused and you will get an error message or anything else to check your configuration once again. And if it's fine, you will see exactly the substation the device will protect. And you will see only these elements in the single line element which are assigned to the 7SS85 and which are valid for the protection. So let's cross the fingers. Ah, it's working. This time it's fine. And you see now what is very interesting. You see in the so-called protection view now really only these elements you have assigned to the device. You don't see these line disconnectors. You don't see anymore the second current transformer because you haven't assigned it. And this is also a very good check whether your configuration is right. Maybe you forgot to assign one disconnector, then it's a valid configuration. For example, if you forgot to assign QB2, then this feeder is assigned or can only be assigned to Busbar 2. It's also possible. But you by yourself have to check whether this is reality or is only the result of a fault by yourself. And maybe Nina, now we have to check. We have all the base. We have the coupler with two CDs. We don't see the voltage transformers. We are not interested in voltage transformers for Busbar differential protection. So it looks quite fine. And what else? You see here all these measuring points, the measuring points of the bay currents and the measuring points of the check zone, of the bus zone, and about the coupler zone. And it's a very good idea now in this filtered view of the single line editor to arrange this measurement boxes, because as you arrange it here now and will save in the same order, you will see the measuring boxes later when you open the online monitoring in Dixie-5 or open the online monitoring in the web browser. So I will do this for Nina, that he will have a good prepared online monitoring for the demonstration in the digital twin later. So coupler BE1 is the left one, the coupler BE1 is the right one. Oh, that's wrong. That's bay 4. Why is it called bay 5? Did I make any?
It's bay 4 and 5, the right ones. But I think
yes, here I have bay 5 and okay. I have to rename this to bay 3 and bay 4. Okay.
I think we can accept that.
Yeah, thanks. But I was a little bit confused for a little moment. So now where's the bay? Oops, where's now the bay 5? 5? No, that's bay 4. I miss bay 5. Here's bay 5. Maybe now time for a little break.
Not yet.
Okay, that's the arrangement of the measurement boxes and the very valuable filtered view to also to make a check whether your configuration is right. Let me have a look what I still want to. Okay, I want to synchronize. I will close. If you see here, for example, here's the disconnector names. That's called bay 0. You want, I guess, in your project you want to name them to bay 01 and bay 02.
Yes, but
Yeah, I think we have this done. Bay 0, it should be exactly the project. Bay 0 and bay 05. And if you select the device and you go here to the synchronize button, then the elements and the names and including the primary rated current of the CDs will be passed from the single line engineering to the elements of the device. It's only a single way top down. It says no logic as to make it the different order from the device to the single line. It's only really to forward the names, the settings from the single line to the device. I will push synchronize. And since the transformer ratio has been changed, the affected parameters may be adapted to the changed ratio. That's the reason why I have changed the primary rated current of the CD in the coupler from 1000 amps to 2000 amps. And as we haven't adapted any settings at all, I can simply say here yes. Okay, and now also this red coupler is going. And we can see here that the name of the bus zones has been are equal to the name of the bus zones in the bus bar, and also here the names of the disconnectors of the circuit breakers, they are equal to the names in the device. So save the settings, maybe to have a look whether also this primary rated current has been changed correctly. We have a look to the 7SS85 settings power system. Let's go to the measurement point 1. Here we see the rated primary current is 1000 amp. And for the coupler it has been changed by the synchronizing with 2000 amps. Now what is missing? I guess one setting.
Yes, we wanted to adapt the setting for the bus coupler differential.
For the bus coupler differential protection. Bus coupler differential protection we have already changed. The minimum differential threshold, yes.
Yes.
So we are in the most important settings. You remember this minimum differential current threshold should be higher than the highest load current of all feeders. It should of course be lower than the minimum short circuit current. And for our demonstration we have decided for a minimum differential current of 1200 amps. The rated object current is 1000 amps, so the threshold of the differential current should be 1.2, and typically the same for the bus zone, 1.2, and maybe as we try to show the thresholds of the circuit breaker failure protection before we assigned any CDs, maybe we have also looked to the settings of the circuit breaker failure protection. Let's go to bay 1, circuit breaker, and now we can see that there's a threshold. The threshold for the phase current is 0.5, means the threshold is 500 amps. And the sensitive is 250 milliamps.
Mm-hmm.
Okay.
Okay.
Nina, do
Yeah,
you
maybe-
want to? Do you have fun with this project now to demonstrate digital twin?
Yeah, maybe one more point. To close the circle, show our customers how to export a SIM file,
Okay, good idea.
which I need anyway
And
later.
that's where to?
Um,
Go project.
On project on the device. In the project tree, right click on the device.
Okay. Sorry. Okay, project. Then export. And then, when I remember correctly, somewhere at the end,
It's the last one, yes.
simulation related data file. C user data. Yes, I would say let's do it to the project. Oops. C system .dixie5 projects, and that should be the project of today, and I will locate the SIM file here.
And this is the file we upload to the digital twin.
Oh, that's great. Due to inconsistency in the file.
Okay, this was a bad idea.
But we have here the SIM. Oh, let's check. Couple overlapping. Advanced. When using the bus coupler differential protection, CTs must not be overlapping.
This is a good hint.
That's a good idea. Let's go to the coupler bay. I guess it is the setting general. Yes. Okay. And here it's marked red. That's by default in the overlapping mode, but we have decided to show the bus coupler differential protection, and when we are using bus coupler differential protection, there's no overlapping because then it makes no sense. So we will change it to no. We will change it to no.
I think you don't just have to do the inconsistency check again and everything will be fine.
I hope so.
I'm quite optimistic. Yes.
Right. Okay, that's live. Okay, let's go once again. I have selected the device. I say project. I say export. I once again. And I nevertheless. Let's select. Okay, it's already still the project directory. Save. Export. Okay, now it's exporting. It takes some time, and it will also take some time by Nina to import in the digital twin.